So here we want to find the domain of a rational function. So rational functions have variables in our denominator. So the problem with this is we have to prevent having 0 in our denominator. So our domain are all of our possible x values that we can have without there being 0 in our denominator. So if we take our problem and we factor our denominator, we say what two numbers can I multiply together in order to get -6, but when I add them together I get -7. -1. So this is going to be x minus 3 times x plus 2. -3 times 2 gives us -6. -3 plus 2 gives us -1. So our excluded values are those values that make our denominator 0. So if we take x minus 3, set that factor equal to 0, and x plus 2, set that factor equal to 0. Our excluded values are -2 and 3. These are the values that we cannot have because it makes 0 in our denominator, which we do not want. So our domain is all of the x values we can possibly have. So we can have everything on a number line we want, except we can't have -2 and we can't have +3. So anything between that we can have, anything to the right of 3 we can use, and anything to the left of -2 we can use. So our domain is -∞ to -2, union -2 to +3, and we're using parentheses because once again you cannot use the values of 3 and -2. Those are your excluded values. Those are the values that make your denominator 0, so they are not included in your domain. Union 3 to +∞. Our equation of our horizontal asymptote, page 319 in the textbook, gives you 3 cases when looking at your horizontal asymptote. Here, your n represents the degree of the numerator, m represents degree of your denominator, and your degree is your highest exponent. So, if the degree of your numerator is less than the degree of your denominator, then your horizontal asymptote is y is equal to 0. If your degree of the numerator is equal to your degree of the denominator, your horizontal asymptote is the ratio of the leading coefficients. So it's the ratio of those numbers in front of the terms with the degree, with the highest degree. If the degree of the numerator is greater than the degree of your denominator, then there is no horizontal asymptote. So for this particular problem, the degree of our numerator is 1. The degree of our denominator is 2. So the degree of our numerator is less than the degree of our denominator. So looking back at our rules, if the degree of our numerator is less than the degree of our denominator, then your horizontal asymptote is y is equal to 0.